Hi all, today we are going to see about our week 4 revision in statistics. What are the topics we have seen in the week 4? Association. Wait just a second. Hi, today we are going to do our stats revision for week 4. So what is the topic which we have seen in the week 4? It is nothing but the association between two categorical variables. So what are categorical variables and all are very well defined by everyone previously. So today we will be seeing the association between these two categorical variables. So now just to understand what is a category, how do we find the association and all, we will take an example between the gender and the smartphone. So as everybody is well aware, gender we consider for female and male. The smartphone is commonly used by both female and male. So now let us take, we have in total 44 female and 56 male in our data set. So among these 44 female, we came to know that 24 of them have their smartphones and the remaining don't, means 20 of them don't have smartphone. In this, among the 56, we can take that 32 of them have a smartphone and the remaining are 24 who don't have a smartphone. So this is the data which we have divided, like on the basis of the gender we have taken the female and male. We have considered female and male, where there are 44 females and 56 males for us, out of which we have collected the data, like on the basis of the smartphone. We could see that there are 24 members of the females who have the smartphone and 20 who do not, and 32 have the smartphone and 24 do not. So to know this, how we need to draw a table or a chart, we just divide the chart. We can draw the chart in this way. This chart or this table which we are going to draw is called as contingency table. Contingency table. How we are going to do? First, we have divided the population on the basis of the gender, like female, on the basis of the gender, female and male. Now we have seen what? Those who have a smartphone. So next is smartphone. That is, yes, those who have and those who don't have. Now just for this thing, we will be calculating the row total and also the column total. So this is the table. This is the table which we have seen. As this is the table, see, the table is complete. This is called as the contingency table. So in the data, what we have taken? We have taken that how many people are having the smartphone. There are in the female. Oh, yes. Yes. In the female, how many have the smartphone? It is 24. And how many don't? 20. How many males have? 32 and 24 don't have. So how do you calculate the row total? What do you mean by row total? We will be just adding up these two. The sum of the quantities in the row. So 24 plus 20 is 44. Next, 32 plus 24 is 56. Next, what you need to calculate? We need to calculate the column total. This is called as a column. So what you are going to calculate? How you are going to calculate? You just add vertically. So 24 plus 32, which is nothing but 56. 20 plus 24, which is nothing but 44. So this is the row total and this is the column total. Now, so what is the grand total? Like how many students? 56 plus 44 is nothing but how much? It is 100. So the entire total is 100 students. So this is how we have drawn our contingency table. How we have seen the association between two categorical variables. Here, what are the two categorical variables? I will just highlight for you. This is gender and smartphone. So this is how we can draw a contingency table showing us the association between the two categorical variables. Next, we will be seeing the relative frequency concept. What do you mean by relative frequency? The observation by the total sum of the total sum. So here, calculating for the relative frequencies, we have two types of relative frequencies. What is it? Row relative frequency and column relative frequency. How you are going to do the row relative frequency? Here we have already got the total of the row as 44. So just one second. Here, so afresh, let us draw like this. What is the total we have got in the row? We have got it as 44. So when it is a row relative frequency, what we do is we sum up all the frequencies and get the row total, and we divide each frequency with the total of the frequencies. What it is, here we are going to divide 24 by 44 and 20 by 44. Then we will get our respective row relative frequencies. Here also we divide it by 56 and we divide it by 56. So this is how we calculate the row relative frequency for the row R1 and the row R2. So this is the row R1 and this is the row R2. This is how we have seen the row total 56, and we have done this. So now we will also see similarly how we are going to calculate the column relative frequency. How? Just the same table I will be taking gender, female, male, smartphone, yes and no. This is total, row total, column total, how we have taken the values 24, 20, 32, 24. 24, 20, 32, 24. This is nothing but 44, 56, this is 56 and 44. I have calculated the table, the row wise tables and the column wise tables. So what we will be doing in the column table or the column, how do we calculate the column frequency? So what was the total? The total is 100. We have seen the total is 100 number of students, where 56 are boys, 44 are girls. We have calculated the two categorical variables here are smartphone and the gender. The smartphone and the gender, and on the basis of how many are having the smartphone, how many are not having the smartphone, we are going to calculate it. So we have already seen how we have calculated the row total and the column total. We have also seen the row frequency, row relative frequency, how we have calculated. So now we will be looking after the column frequencies or the column total, how we are going to calculate it. What we will do in the case of column, we will just take the total values of the column and divide each frequency of the respective column with the total frequency of that particular column. So 24 divided by 56, 32 divided by 56. Here the column total is 44. So 20 divided by 44 and 24 divided by 44. This is how we calculate the column relative frequency. So now we have seen how do we calculate the row relative frequencies and column relative frequencies. So now we will go with another topic called as association between two variables. How they are associated. The main goal is we will be knowing how two variables are getting associated, either with the row relative frequencies or the column relative frequencies. Now we will take the same concept here, association between two variables. How we are going to see association between two variables. So here we will be looking after the row relative frequencies and the column relative frequencies. One important note which you need to know is, if the row relative frequencies or even column relative frequencies, row relative or even the column relative frequencies are the same for all rows or columns. If you take column relative frequency, it is for columns. If you take row relative frequency, it is for rows. Then we say that two variables are not associated with each other. So whenever the row relative frequency for all the rows or the column relative frequency for all the columns are same, then we can say that the two variables are not associated with each other. So if they are associated, how can we say they are associated? When the row relative that is column row relative or column relative frequencies are different for all rows or columns, then we say that the two variables are associated with each other. Then we say that the two variables are associated with each other. So now if we take the same example as we have taken earlier regarding the column frequency or the row frequencies, row relative frequency and the column relative frequency, we could say that 24 by 44. What is the value of 24 by 44? It is, what is the value of 24 by 44? What is the value of 20 by 44? 32 by 56, 24 by 56. We could say that each value, 24 by 44 and 20 by 44 are different. 32 by 56 and the 24 by 56 values are also different. So now we can easily say, just no need to calculate and decide whether these are associated or not. If you even just look onto the values, see 24 by 44 is obviously different from 20 by 44. 32 by 56 is completely different from 24 by 56. So the values are different. So we can we can see that there is a relationship or association between these two variables, smartphone and the gender. So next we will be watching the stacked bar chart. The stacked bar chart. What do you mean by a stacked bar chart? The next topic is stacked bar chart. So whenever we take a data of, let it be female or male or any category, we want to represent in type of segments so that it is clearly known it clearly depicts us what is the current situation of the particular data which we have taken. So now here if we consider regarding the smartphone and the gender. Okay, let me write it. Smartphone and gender. We can draw a 100% stacked bar chart. How? See, I will just take like this. With respect to the gender, I will be drawing the graph with respect to the gender, male and female. How? Male and female. So let me take this to be female, let me take this to be male. This is zero. Let us take female, male. This is nothing but gender. This is nothing but the count. Like we can take the frequency distribution like 20, 40, 60, so and so. So how many females have the smartphones? There are 24. So here we will be taking 24 means this. And the remaining a different color so that it tells us the percentage. it shows us how many have taken the bar graph, how many have the smartphone, and how many doesn't have the smartphone. 32 has. So see the graph over here, or the I'm just drawing with rough hand. So this is the percentage, or these many people are there who don't have the smartphone in males. These many people are there in the females, those who don't have the smartphone. So this is how we will do. Now if somebody says to look over and presently describe how many have the smartphone, how many don't have the smartphone, a stacked bar chart helps us to completely give a complete picture about the percentage of the males, or the number of males who have the bar chart, who have the smartphone, and who don't have the smartphone. So a person, if he looks just in random, he will come to know those who have. Always do remember, in a chart we do write these: have, don't have. So this don't have indicate the persons, those who don't have in the males or the females, and this one indicates the persons who have in the both females and males. So this is what about the stacked bar chart. The main importance of the stacked bar chart, or the main purpose of the stacked bar chart is, this helps us, this bar chart is useful to part to whole relationships. This is why the stacked bar chart is used. So the next one we are going to look after the association between two numerical variables. Two numerical variables. What it is, how do we understand? We will just use the scatter plots, and we will protect the association in between the two numerical variables using the scatter plot. So first we need to know what is a scatter plot. What is a scatter plot? It helps us to find the association between two numerical variables. It is a graph that displays the values as points on a two-dimensional plane. What is a two-dimensional plane? This x-axis and y-axis. This is called as a two-dimensional plane. What is this? This is x-axis and this is y-axis. When we were young, we used to say that independent variable and dependent variable. Now as we are grown up, now we will use the exact statistical word, where x is called as the explanatory variable. And y is called as the response variable. So this is our scatter plot. These are the first two names of our x-axis and y-axis. One is the explanatory variable and y is called as a response variable. Now let us take, for example, an common example which we take in our schoolings and all. So now let us take two variables, age and height. Always remember, when you are writing, it should be defined age in years, height in centimeters. For which group age we are going to calculate? 1, 2, 3, 4 and 5. What is the height? 75 centimeters, 85 centimeters, 94 centimeters, 101 centimeters and 108 centimeters. So now what we will take, which is explaining, we are going to find the relationship between the age and the height. So age will be our explanatory variable. This is going to explain you what the whole chart is shown using the age. So 1, 2, 3, 4 and 5. We see here the height over here is 75. So at a stretch we cannot start with 75. We need to just truncate it because 75 is a larger value. We take 75, 70, 80, 90, 90, 100, 110. How you are going to draw? For 1 it is 75. For 2 it is 85. For 3 it is 94. For 4 it is 101. For 5 it is 108. So you could see that here this is a two-dimensional plane, as it is like x and y is a two-dimensional plane, which is explaining the graph between the relation between or association between two variables, age and the height. Now we could see that each point over here describes us about the association. See, we can do this. So this is the scatter plot which we have seen now. Now we will take the visual test for association. Generally this is for a very small data I have taken of 5 numbers. Now if I wanted a larger number, now what I mean to say is, if we are collecting the data for a very larger number of size, the data set sized 100 members. So how would it look? See, now we can just draw. Yes. Now we will be drawing two data sets. So this is the data 1 set, data set 1, and this is the data set 2. This is data set 1 and data set 2. I will show you how we are going to consider or conduct a visual test. Visual test for association. How we are going to do? Now let us take the same explanatory variables as age and the same x-axis and y-axis, response variable as height. So we have truncated the distribution 70, 80, 90, 100 and 110. Response variable x-axis, explanatory variable. So height, this is the response variable and this is the same data which I am going to take. We are going to draw the edges 1, 2, 3, 4 and 5. Here 1, 2, 3, 4 and 5. Now I wanted to see some data I have collected for 100 people. I got the data like this. Suppose like I have conducted this in the test of Mysore. Here I have conducted for Calcutta. The data set sizes are same, they are 100. So this is the data set drawn for Calcutta. So here in both the graphs we could observe that the first graph, the data set 1, is following a pattern. We could see that it is increasing and it is increasing rapidly. But in the data set 2, we cannot see that there is some pattern or anything. They are just scattered. So this is how we do for the visual test for association. Now, how do we describe these associations? We can describe these associations with 4 parameters. What are those? Those are nothing but describing association. How we are going to describe the associations? We are going to describe them by 4 parameters, that is direction, curvature, variation and outliers. What is the direction? How we are going to find the direction? So whenever we draw a graph like this, x, y, 0, like companies and the shares, the present topic which everybody can understand, A, B, C, D, shares, let it be 8, 16, 24, 32, so and so. So if this is the direction, we could see that there is an upward direction. If suppose in the same graph, not the same graph, if suppose we could see that this is the direction, we can say that this is the downward direction. So this is an increasing direction, this is a decreasing direction. So similarly, if suppose we need to see about the direction, both, there are chances where we could observe that there is both inclination and declination, means increasing and decreasing. So for like companies and shares, let us take this also for the different state. So both increasing and decreasing simultaneously you are able to observe.